Thank you, everyone. Good afternoon to the CCIR team, fellow presenters, ladies and gentlemen. My name is Aarush. I am a high school student at Dubai College, incoming year 13. And I'm very thankful to CCIR to present my research today, which is titled The Illusion of Control, Perceived versus Actual Agency, Control, and Authorship in Generative Music Systems. So I know it's quite a mouthful, but hopefully by the end of this presentation, you'll have a better understanding of what my research is essentially about. So the way this presentation will be structured today, I'll give a short introduction about myself and my mentor. Then I'll talk about the background, kind of the field of AI and music. It's a very recent field, so I think this is a very timely kind of presentation. Then I'll talk a little bit about Markov chains, which are a way of using math and artificial intelligence to compose music. And then lastly, I'll talk about our study, our research methods, and kind of future directions. So a little bit about me. I'm a high school student from Dubai. I play the piano, drums, and percussion, like the marimba, the xylophone, etc. I'm kind of interested in math, physics, computer science, music, environmental sustainability, so a lot of interests. And my primary kind of academic interest is the intersection of computing, music, and creativity. So that's what I'm really interested in, and that's what I hope to study kind of in more detail at university. So I began my CCIR project in January, and my mentor was actually Dr. Advait Sarkar, who gave the opening talk today. So I'm very grateful for all his support with the project. And as he mentioned, he's an affiliated lecturer here at Cambridge and an honorary lecturer at UCL. So now to begin the actual presentation, I'm going to talk a little bit about the background, the kind of field of AI and music. And I think the best way to do that would be to give you a timeline of how this field kind of progresses. So what I've selected here are kind of four major events in the field of computer music. So the start, well, computer music doesn't start in 1957. It goes way beyond that. One of the earliest examples we can think of kind of composing music using algorithms goes back to the invention of musical dice games. These are kind of German games where you would roll a dice, and each dice would correspond to some sort of music, some sort of melody. And essentially, by rolling the dice enough times, you could build a piece out of a certain kind of data set of musical elements. So, of course, you're leaving it up to chance. You're rolling dice, so it doesn't sound very good. It sounds more like cacophony rather than music. So that's why we don't really consider that computer music or algorithm music just yet. But the main kind of first piece of music to be written by a computer was the Iliac Suite. It was a string quartet composed by the Iliac computer at the University of Illinois, Urbana-Champaign, by professors Legerin, Hiller, and Leonard Isaacson. So they composed kind of the first piece of computer music. What they did was they gave an input to this computer, and they asked them, can you compose us a piece of music? And they ran the experiment 4 times, and each kind of output sounded a little bit different. The first movement of the music focused on rhythm, the second focused on polyphony, etc. Then we progressed to 1996, where we have experiments in musical intelligence. That is basically a program that was developed by David Cope, and he created an AI system that essentially allows you to compose music in the style of a composer, of a certain composer. So for instance, he ran it on Bach, Mozart, and Chopin. Next, around the same time, in 1996, we also had Pure Data, which was developed. So Pure Data is kind of a visual programming language. So very similar to kind of a flowchart. You can drag and drop elements, and that would create electronic sound. So you can start with the very fundamentals, because again, all sound, all music is just sine waves. So you could run sine waves in this kind of environment and kind of layer them to actually create unique sounds and eventually music. And now we fast forward to kind of the present. Just very recently, 2023, 2 years ago, we had the development of this big AI tool called Suno AI. So Suno AI, I don't know, has anyone used or heard of Suno so far? No? It's kind of like the most state-of-the-art AI tool we have right now. Essentially, you can literally write a text prompt like ChatGPT and say, develop me a song in the style of the Beatles, for example, and it would develop you a full 1-minute song, literally in that style, with lyrics, with instrumentals, with vocals, with everything. So it's really amazing, like what kind of AI tools we have right now. And actually, I made an example for you guys to understand like what we're kind of dealing with. I prompted Suno and asked it, could you create us a disco song in the 2000s? And hopefully the sound comes through here, but this is what it made.
trips quick and I can't even think. Oh, you move like a funky groove machine, spinning wild in a disco dream. Oh, you shine like a mirror ball queen. Funky.
Yes, that's essentially kind of the tools that we're dealing with. You know, you have these AI tools which are so amazing now. You can literally write it a single prompt, and from that you're getting a song of, you know, this caliber. I think when I first heard of Suno, I thought this was a real human kind of singing this, but it's not. It's all AI generated. And just like Suno, we have a lot of other tools like Ava and MuseNet from OpenAI, which can do similar things. And so that's kind of the place we are at right now with AI and music. So if you remember back to our first slide, when I kind of introduced my research, I talked about these three key terms: agency, control, and authorship. I wanted to kind of formally define them before we go any further. So the definition that we've adopted is that agency is a feeling that users are driving the interaction and not being driven by it. Control is a user's ability to influence the system's behavior and its outcomes. And authorship is a user's role in originating and being recognized as the creator of content or actions. So just to be clear, these are the definitions we're adopting for the purpose of this study. So now I want to cover, why does this research actually matter? So we've seen that AI is pretty cool. It can compose really good, high-quality music. So why should we even research this topic? Well, the main reason why I think this is worth researching is because the current state of AI tools is very unsustainable. So many studies have actually showed that these AI tools could actually reduce creativity in humans because you could simply rely on the AI tool to make music. Very similarly, in MIT, nearly, I think a month ago, there was a study by the MIT Media Lab that showed that using ChatGPT to write essays could actually reduce your creative and critical thinking skills. The way they did that was they hooked up electrodes to people's brains and kind of monitored their brain activity while writing essays. So very similarly, a music production company called Ditto, it ran a survey and it found that 60% of surveyed artists use AI tools in the music production process, and this number is growing. So it's very kind of timely, I think, that we're working on research like this because we need to build AI that augments creativity and not diminishes it. So how do we actually do that? How do we build AI that kind of works with the user rather than doing the work for them? So a lot of prior literature has focused on this issue, and the main studies that we're kind of looking at now show that we need more co-creation tools for AI. These are essentially tools where an AI and a human will collaborate rather than the AI relying on the human relying on the AI. So the most promising suggestion that has been developed this far is called music steering tools. And this is Dr. Ryan Lewis from Northwestern University. And he developed this tool where you would have an interface kind of like Suno, but instead of just prompting it, you would have kind of features to control the output of the music. So you would be able to change, say, the tempo of the music, the dynamics, so on. That basically allows a user to have control over what's being generated, right? Suno at the moment doesn't have anything like that. You have to rely on the fact that you hope that the AI is generating what you want it to generate, not what it wants to generate. So that's basically the way it currently works. We need to develop more tools with AI music steering tools. That is what is being dubbed as. So our main research objectives here were on user interaction and new insights. Essentially what we're trying to investigate in this study is how do composers interact with Markov-based composition tools within their creative workflow. And in terms of the new insights, what drives user engagement in generative music systems in terms of agency, control, and authorship. So now we're going to move on to the next part of the presentation, which is on Markov chains. And these are essentially a statistical model to compose music. So now to understand Markov chains a little bit, you can kind of think of it in this way. It's a mathematical framework to kind of understand that what happens next depends only on what happens now. So you have these things called states, and you work out the probability of going from one state to another. So for instance, we're in Cambridge right now. We can take an example of the weather in Cambridge. Let's say, for example, that the weather in Cambridge can only be rainy, cloudy, or sunny. Only 3 states, right? Those are our states for this matrix. We can then consider, maybe if it's rainy today, what is the probability that it will be raining tomorrow as well? According to our model here, this example, the probability of it being rainy tomorrow, if it's rainy today, is also 0.5, and so on. So if we construct a diagram kind of like this, we have our Markov chain state transition diagram. That's what we call it, a state transition diagram, which states that if you're going from one state to another, say rainy to cloudy, And if it's rainy today, what's the probability of it being cloudy tomorrow? In this case, that would be 0.3. So once you have kind of this whole state transition diagram, you can set up this thing called a state transition matrix, which is at the bottom. And that will be really useful when it comes to the applications in music. Mathematically, you can think of this that the probability of something happening next only depends on what's happening now. So between two states. Now, in terms of music, we can think of every sort of musical melody as a combination of some of the 12 notes. So in Western classical music, we have 12 notes, as you can see on the keyboard. And every melody will consist of a mixture of notes, some or a lot of notes from this kind of keyboard. So for instance, Happy Birthday would be C, C, D, C, F, E. And that's an example there. So all music is essentially constructed from these 12 notes. What we've done is essentially we've made a Markov chain. As an example, as I said, Happy Birthday, C, C, D, C, F, E. And what we can do is we can use Markov chains to take that melody and make something new from it. So if we think of this melody here, we want to model it as states, right? We could think of each note as a state. For instance, C is a state, D is a state, E is a state, and F is a state. Then we can kind of consider the probability of jumping from one note to another. For instance, in this setting, the probability from going from C to C, that only happens once. And going from C to D, that also happens once, the next note. D to C, that happens once. C to F happens once, and F to E happens once. Once you have a more complicated melody, you'll have a larger number of notes, and your matrix won't have any kind of zero elements. Then we can normalize this matrix using a normalization algorithm, counting kind of the total number of jumps between notes and then dividing it through. And you're probably wondering, how does this even help us? So let's say this is our Markov chain matrix over here, the one in the middle of the screen with our decimals. Let's say we input the note C into it, which we can denote as 1, 0, 0, 0 at the end. If we multiply our transition matrix by 1, 0, 0, 0, we get this new matrix at the end. And essentially what that's saying is that we have a 33% chance of the next note being a C, a 33% chance of the next note being a D, and a 33% chance of the next note being F. And there's no chance of it being E. So using our Happy Birthday melody, we've kind of developed a probability transition matrix of new notes that we can transition to. Now, if we recursively use this matrix enough times, we would have a full melody. And that's exactly what we've developed. Myself and Dr. Sarkar, we programmed our own system in Python, which looks a little bit like this on the right of the screen. And essentially how the system works is that you can plug in a MIDI keyboard such as this to your laptop, and you can play some sort of melody, and it will kind of analyze that melody and compose a similar melody to it. So the way we envision it is sort of an AI composition help tool. It helps composers generate new ideas, and that would be really helpful when you compose new music. Now let's actually go over the research methods and our study in more depth. So in the case of this study, what we really wanted to know was, does a user's sense of engagement with an AI system actually come from having control, or is it due to the illusion of having control? So what we did was we developed two systems using the same UI pretty much, and in one system, all the controls worked, all the music steering tools worked. For instance, if you slid the randomness slider, that would make the melody more random. It would include some really dissonant kind of harsh sounding intervals, right? And all the controls here work. Direction bias would make your melody ascend, go up, or go down, depending on how you chose it. However, in system B, our placebo system, we actually made some of the controls such that it does nothing. So for instance, a randomness slider, you can slide it across, but it has no effect on the melody being generated. Similarly, you can choose a mood over there at the bottom, such as maybe you want it to be in an upbeat mood, but that would also have no effect on the melody being generated. So what we did with these two systems was we made a user study of n equals 20 participants, and this study is actually ongoing. So far we've conducted about 4 to 5 interviews, and we're kind of working on this right now. And we're splitting the participants by giving them either the control system and the placebo system in either order. And they were given these two melodies for each system, and they were asked to compose another melody for each thing. So for instance, if I was an interviewee, I would be given control system A, and I would be given these two melodies, and I would be like, you have this tool for you to use. You can use these tool with these melodies, and you have to try and compose something with it. And that was essentially our study. We didn't tell them that which kind of system was the control and which system was the placebo, so that was unknown to them, and they were interacting with both systems. After each interview was done, the interviews lasted around 1 hour. They were asked a few questions about their creative experience. For instance, did you enjoy working with the tool? The questions are actually here. These were our interview protocol questions. These are what we asked them. So for example, for system A, we might have asked them, did the system's output feel musically interesting? Did you feel engaged during the composition process? Do you feel you had an effect on the melodies generated by the system? And then we kind of recorded the answers verbally to these questions. And of course, the criteria for this study was that participants had to be able to read and write sheet music notation. They had to have at least 1 year of music composition experience, and they had to have an understanding of music theory concepts. So with all the data that we've collected, and as I mentioned, this is an ongoing study, from what we've collected so far, we've taken the interview transcripts and then we analyzed them using Braun and Clark's qualitative thematic analysis framework. And that's a framework we kind of used, generating codes and then themes from the interview transcripts. These are some of the key quotes that we had from our participants so far. So for instance, one participant said, I feel complete ownership because both systems give me a direction to go in. And that is exactly what we're looking for. We're not looking for the AI to do the work completely for the musician, rather give them a starting direction and let them kind of be inspired. Another participant said, I thought it was really cool to put in those 2 sliders, mood and genre. Clearly, they didn't know that that was actually a placebo feature. They thought that it was actually helping them and changing the melody, but those were in fact placebo features, and they had no effect on the melody generated. And another participant said, I preferred system B. The extra options of the genre and mood sliders was great. So again, this participant didn't understand, well, of course, they didn't know that those 2 sliders were indeed placebo features, and they kind of thought that that was helping them in terms of the composition process, but it actually had no effect on the melody generated. Another participant said, in terms of the ownership with the output, I think it's pretty much the same. So that suggests that both their systems are having some effect on the composition process of the musician. Now, in terms of kind of our conclusion here, of course, the study is still ongoing. We don't know completely which direction it could take, and the rest of the participants are yet to be interviewed. But it seems from the 4 to 5 participants we've done right now, there seems to be some suggestion that having more options with your music generation system, more ways to control the melody, is correlating with kind of increased engagement with that system. So that seems to be the general consensus that we're getting right now. And this was my reference list for today with the sources that I used in my study. And thank you very much for listening. Any questions?
So thanks so much, Aarush, for the really amazing discussion, especially considering AI music not something you typically put together. And I just wondered then, to kick off the questions myself, where do you see, or where do you place the ideas of originality and copyright? Because at the end of the day, the AI is generating the content whilst the human is giving the prompts.
Yeah.
So who actually creates content? Obviously, if they are creating content giving prompts, perhaps AI is giving similar content to different people. So what are the conflicts or ethics around this, in your opinion?
Yeah, I think there's definitely a gray area around ownership right now with AI music systems. So for instance, I'll give you an example. When I used that tool Suno at the start to generate the songs that you heard, initially I tried typing in, could you generate a song in the style of the Beatles? But obviously it didn't let me actually enter that, and it said you have to kind of change your prompt. So I think with ownership and creative output, there's definitely a gray area, because of course these AI models have to be trained in something in the past. And there's definitely also issues with kind of who is going to let these AI models be trained by. Do you give consent to let the AI model be trained on your song? So I think there's definitely a gray area there which hasn't been fully explored. That could be a room for like future studies and looking into ownership over, especially not just in the music field, in fields like art and drama, where there's a lot of creative expression required. So I think that's definitely a valid thing to pursue in the future.
Yeah, it's a big issue in PR as well at the moment. Yeah, any other questions opening it to the floor? Just on water silence.
Oh, yeah. Felix? Yeah.
So, for the matrix that you mentioned,
Yes.
is that probability like, you decide that for each genre of music, or is that like
Okay, so I just want to clarify one thing. The genre and mood sliders were placebos. So like I said, they have no effect on your melody generator. They're doing nothing in terms of the math underneath the hood. Just to kind of reiterate on the matrix part, I don't think I explained it very well, but so what I've done here on the left-hand side over here is I've counted the number of transitions between each notes. So for instance, I've labeled the notes here C and C, there's one transition. C and D, there's one over here. And then D and C, one over there. F and E, one over here. And C and F, one over here. If you had a longer melody, you could have 2s, 3s. This is just because we have a short melody. That's basically the counter, how many times we're transitioning between. As you can see, there's 5 notes in total, and over there is also 5. 5 transitions, sorry, not 5 notes. There's 6 notes, 5 transitions. Then what we do is we kind of sum the total over here, so 1, 2, 3. So for instance, if you start in a C, if you start on the note C, you can move to 4 possible destinations, right? C, again, D, E, or F. But in the case of our input melody, which is this, we're getting 3 because it doesn't ever go to E. As you can see over here, from C to E, that transition doesn't exist. So we kind of sum these numbers over here, and then 3, and then we divide each individual element by 3. So then we get 1 over 3, 1 over 3, 1 over 3. Since there's only one count over here, we get 1 and 1 over there. You'll notice that in the matrix, we actually have zeros, right? That poses a problem in the future, because as you can see, if I run this transition matrix on the note C, which is 1, 0, 0, 0, at the end over there, I'm getting that other matrix, which represents the chances of going to different notes. So as you can see over here, if we start in a C, there's a 33% chance of going to the other 3 notes, except for E. There's a 0% chance for that. That means if you run our matrix on that, it will never ever go to an E. So in terms of the music, it'll sound kind of stable, especially when you have a longer kind of melody with all 12 notes, and let's say you have some zeros in your matrix, it will sound pretty incomplete. So to take care of that, we used a process called additive smoothing, which I didn't actually touch upon here, but basically we added a small probability to each item in the matrix, say 0.001, and then renormalized everything, so it all sums up to 1. Like as you can see, each row sums up to 1, except for this one. Like I said, we need to add the small probability, so it sums up to 1. And that process, additive smoothing, makes it so that the more likely notes here, such as C, D, and F, will still remain more likely, but the probability of going to a less likely note, such as E, there's still a little bit, you know? It's not completely 0, so it can jump to that note. And that makes the music a lot more varied, and it makes it, you know, sound like actual music and not very volatile. So yeah, does that answer your question?
Yeah. So it also works for like a 12 by 12 matrix.
Yeah, exactly. So I've just done a 4 by 4 here because just for space. But in your actual computer, like when I'm calculating it, it would be a 12 by 12 matrix because there's 12 notes as I showed before. Yeah, so you would have a 12 by 12 matrix with each note. And then again, like I said, the zeros become a problem because in 12 by 12, you have 12 times 12, so 144 possible transitions. So if you have zeros, that poses a problem. That's why we use that process called additive smoothing to add a small probability to each item in the matrix.
Can I ask how long like one generation takes?
It's actually pretty fast. It takes maybe 2 seconds. And also in our software, we have a way to also hear it and also to kind of visually look at the score. So like a lot of musicians like myself, I can hear something, but I can't play it back very well, so I need kind of a score. So that's a feature that we added. And I think our participants really like the score feature, so they can not only hear the output, they can also kind of view it and play it back. Yeah. Thank you. Yeah. Yeah.
I was just curious, this is more to do just with like AI and humans in like a collaborative sense. As AI becomes more advanced and might reach singularity, do you think that poses like any problems with humans and AI being like not just us asking AI things but actually working with it?
Do you mean like in terms of AI being sentient, or like as in actually being able to think kind of and do its?
Yeah, kind of like I read somewhere that like AI has started not like normally with, like for example if you use ChatGPT it will show like all of its reasoning, but it started kind of not doing that, like in ways that we don't understand as well. Do you think that like in that sense it poses a problem?
I think for sure. I think so. I think Dr. Sarkar kind of mentioned it in today's keynote as well. I think AI, the main purpose we should be using it is to augment our kind of creativity. It should be used as a starting point, like somewhere to go. So I think if it's not giving its full reasoning, say in a chatbot like ChatGPT, that doesn't give you a really good idea from like where to go. So I think definitely AI models should be used in AI tools as like a starting point for creativity, but it definitely shouldn't do the work for you. And that's exactly the whole reason why we did this study, to try and find better ways to make AI boost human creativity rather than diminish it. Yeah, sorry, which?
Can I ask? So most of the examples you've used here are from Western classical
Yeah.
music, and even what you've worked with is mostly Western classical music. So I was just wondering, like, would these AI systems, like, would they work in a similar way for other, like, types of other music from different cultures?
So
Different scales and notes?
Yeah, I've been trained as a Western classical music, so that's the reason we kind of adopted this. But I'm thinking, I know a little bit about Hindustani classical music, Indian classical music. As long as you have, it could even work for rhythm, say like drums, but you need to have states, because again, like I said, it all relies on kind of the Markov chains. So as long as you have some sort of system with states, like in this case, we've made the different notes of a keyboard states, right? If you have, different drums as the different states, you could even generate that as music. So that's all that really matters, that there's different states and there's transitions of going in between these different states. Yeah. Yeah.
So just as a follow-up, I understand that in music, Hindustani in particular, that pauses within the music is incredibly important. So I was just wondering, have you found a way to quantify the amount of pause between certain notes, or the probability that, say, from like the baseline note to a mid note within the octave, like quantifying the probability and time frame that it takes to go from one note to another. Because I understand that it is important, not only in like vocal music, but definitely in instrumentation and drums as well.
So one thing to clarify is that our system only does melody. So it doesn't do harmony, and that was actually something intentional that we did, because we didn't want it to do the whole work for the composer. They should figure out the harmony themselves. And also, like you said, in terms of rhythm, it always does everything crotchets. So like 1, 2, 3, 4. It doesn't do any more complex rhythms like. It always does crotchets regardless. And that was also another decision we made, so that what's being generated is simple, and the user has to use their own imagination to develop the rhythms. So you could do rhythm, we chose not to, and that would also be done using Markov chains. So you could, like I said, if you have any sort of states, for instance, a crotchet is one state, a quaver is one state, a dotted quaver is another state, it would also work. Harmony, you could also do that using Markov chains. For instance, different chords are different states. Pauses are a bit difficult, because you would have to maybe make a separate Markov chain for different lengths of pauses. So, but I think it would definitely be possible. We haven't looked into that, but that's also on the programming side, so technically it should be possible. Yeah.
I'm a physician, so I'm going to approach it from a very different point of view. But it just occurred to me, I don't know if you had a chance to look into it. I'm thinking the area of creativity in the brain is different from the area of mathematical equations. So when it comes to music, when it comes to creativity, one part of the brain actually thinks of the music, it just comes to you. But if you rely on something else to help you, that might shift, thereby affecting creativity. Have you ever thought about that?
Yeah, for sure. I think it's really important to make sure, like I mentioned the MIT study at the start, it was a very recent study. They actually got a bunch of participants to write essays, college level essays, and then they gave one set of participants just Google search, and the other set got AI tools, and they showed that the participants that use the AI tools, they had fewer kind of alpha to beta ratios in their brain activity, which correlates with kind of less creative thinking. So I think definitely it's probably worth looking into how, when you use these AI tools, that, well, the MIT people have studied that when you're writing essays. Did that also happen when you're composing music and other creative forms? But I think my suspicion is most likely it does. I think using these AI tools it definitely does reduce creativity for sure. Like even I've used certain tools, but I think that's why we need to kind of design more responsible tools like these that are kind of designed in such a way that they need to augment creativity and not diminish it. And they don't do the full work for the composer. They give them a starting point, and then the composer has to use that and go away and work on it themselves.
Any further questions?
Perfect. Let's give one round of applause.
Thank you.